Well, hello, everybody, and welcome to the National Student Data Corps Masterclass Series. We're so excited at the Northeast Big Data Innovation Hub, which created the National Student Data Corps, to host this really important series that we're starting just this year in 2023. In the National Student Data Corps, we created the NSDC, as we call it, at the end of 2020 with a founding committee from the community of 24 people who wanted to help us create a way to provide open, accessible data science awareness and education to students across the Northeast region, across the country, and around the world. Since then, from zero, we now have over 4,400 people engaged in this community, and we reach 28 countries around the world. And we're delighted that people find so much value in this. When we first started this, we wanted to show the different types of roles and jobs that could be available with data science. And we had a data science career panel series, which was more like a buffet, or like we'd have a range of different presenters from different aspects. Somebody from Warner Music about data science, someone from bioinformatics. Now what we're doing is bringing in experts like Svitlana today to actually talk about the use of data science, artificial intelligence in specific domain areas, and from specific points of view regarding tools and techniques you could use. So we're delighted that in this episode, episode number 2, we're talking about generative AI, or generative artificial intelligence, where Svitlana is an expert. Generative AI has become very popular in 2023 with ChatGPT, and there's a history there and the future. So we're delighted that Svitlana, the Chief AI Scientist in the Office of Science and Technology at Aptima, is going to be our Masterclass Series presenter today. And Emily Rothenberg, who's the NSDC Program Manager, and I are delighted that you can join us. So Svitlana is going to do her presentation, and then we'll have a moderated Q&A discussion, which will be a lot of fun. So we're going to pass it over to Svitlana now, and we can get started.
Can you see my screen? Okay. So thank you so much for the introduction. Today I'm going to be talking about generative artificial intelligence and how we got there, and what are the risks and limitations and how we address them. We have been on this journey to generative AI for the last 5 years, really fast. Everything evolved, and we moved from generative pre-trained transformer models that are that have millions of parameters to trillions of parameters. So the first models had 170 million parameters, versus GPT-4 is over a trillion parameters. And we also have important people like the CEO of OpenAI, Sam Altman, testifying in front of Congress. And I really encourage everyone to watch this TED Talk by Yajing Choi, professor from the University of Washington. She discusses the limitations and the next steps for generative AI. So we're living this exciting era of generative AI. And what does it mean for us? I want to point your attention that there have been a huge improvement in AI systems, not only generative systems, but in general in AI systems across many domains. And as you see from especially after 2010, there is huge performance improvement where where on the y-axis you see the relative difference between human versus machine performance. And you see AI systems, they are outperforming humans significantly across many tasks: reading comprehension, image recognition, speech recognition, and you call the bank and the AI system is able to recognize you well, handwriting recognition, and recently language understanding. So with language understanding, there have been these new models that are called large-scale language models that we're going to talk about today. Why all of this is happening? There are multiple reasons, and we will discuss all of them. First of all, large amount of data. So these days, these models, generative models, or in general AI models, they are trained on terabytes of data on the internet. Second of all, extreme scale computing. There is a lot of compute needed to really pre-train these models. Third, in context learning. This is a new type of learning that we're talking about. It's not supervised, it's not unsupervised, it's in context learning. And finally, the actual model architecture, transformer models. And if you look into this chart on the right, you see different modalities that the papers have been published on across AI conferences. And you see there have been a huge increase in publications on text, specifically about large language models. You have less in images and other multimodal models, right? So this field is evolving very fast. If we talk about large-scale models, you can see the architecture evolution specifically for language models. I really like this visualization because you can see that you can see different branches. So there are different types of models: encoder models versus encoder decoder versus decoder models. This is a specific type of transformer models. And you can see that there are a lot of decoder models, decoder only models that have evolved starting 2018. If we think about these models, they're ginormous. They are trained on 1 to 2 trillion tokens, which equals to human reading 8 hours a day for 22,000 years. There is no way a human can read for 22,000 years. And we have also, my team has also been working on it and pre-training these models from scratch, which is very compute intensive across multiple domains in text and code, as well as text and molecular representation. So there is a lot of potential to go across modalities here too. And what do we mean when we say very huge scale? We mean a lot of GPUs there are a lot of GPUs are needed to train these large scale models. And on the left-hand side, you see the evolution in the model size over these years, right? We go from GPT-3 to like Megatron Turing to Palm models, and there are more and more models that are appearing every day, literally. What does it mean to pre-train these models at this large scale? It means that these models can show these emerging capabilities. On the right-hand side, I'm showing you different models: Lambda, GPT-3, Gopher, Chinchilla, and others. And on the y-axis, you see accuracy, and how accuracy depends on the number of parameters. The number of parameters is the size, the scale of this model. So as you see that the accuracy starts significantly improving across many of these tasks, as long as the model size grows. And that was the discovery and this emerging behavior of these models. That is, on one hand, is a huge plus, right? Because these models can do more than what we expect them to do. But on another hand, this emerging behavior is unexplored and it's new and we don't know what to expect, right? It's difficult to test. And if we talk about the transformer architecture, this transformer architecture was developed in 2017. And on the right-hand side, there are all of the papers that have been published since then. And as you can see, the architecture hasn't fundamentally changed over the last 5 years, which is a lot in the AI field. We learned how to do some cute position encoding and attention and tricks here and there, but fundamentally the brain behind this model is the same. What changed? Why this generative pre-trained transformers and other generative AI models are so successful? This is because of the type of learning. So we AI scientists, we fundamentally changed the way that we train these models and the way that we interact with them. So it all started with the deep learning era, right? Where the models, we fundamentally focused on representation learning. We learned how to take raw data and encode it with embedding vectors. And the models were fully supervised, where you feed the model the examples of the examples that are fully labeled, and you come up with a new architecture design. Every paper that we published until probably 2021 had a new architecture design. Then we moved into this era of pre-trained models, where we significantly explored transfer learning. So there was, for example, a bird model, and we took it and we fine-tuned it on our data. There was new architecture design. But right now we live in the era of large-scale models and in context learning. So what we do, the way that we teach the model and adapt the model to our domain or to a new task, we just pre-train, and we take a already developed model by OpenAI or our other company, and we just interact with it. We prompt it, and we prompt it in a zero or few shot learning. What does it mean? It means that these models can be applied to new tasks out of the box. You never train the model for that specific task, but the model, after a few examples and a few interactions, this model can be adapted easily to a new task. And what we see is that good performance is observed with only a few examples. Literally, you can have a few prompts and your model is experienced in a new task. So tasks are adapted to models rather than models are adapted to tasks, right? So these are the differences between the deep learning models versus large pre-trained models and in-context learning. And humans interact with these models using natural language. So the way that we interact with ChatGPT is using natural language prompts, which completely blurs the line between model developers and model users, which I think is fascinating. And that's what is going to be happening more and more. But you may wonder why ChatGPT was so successful. I think it was a brilliant social experiment when the model was totally open to the world and everyone was allowed to interact with the model and this data was collected. And after the data was collected, it could have been used to make this model even better from human preferences. But before that, what OpenAI did, they trained a second model, which is called reinforcement learning with human feedback, that learned from human interactions when humans basically they rated the model responses. They said, yes, good response or no, bad response. And then learning from that data at huge scale allowed to basically develop a model that is appealing to human preferences. The model that is that it basically leverages what we would like to see in the outputs. And so far, we talked about only large models, right? Large language models, but there is more to it, right? So there are more modalities to just text. And there was this notion of foundation model term that was coined by Stanford, I think 2 years ago. And the notion of this foundation model, otherwise called pre-trained models, where you have different modalities going into one brain, into that foundation model. And this model can be rapidly adapted across many tasks, right? You see image captioning, object recognition, sentiment analysis, and so on. And then since then, the foundation models that have been developed for decision-making, for the health domain, and so on. And transformer architecture is actually very well applicable across modalities. So you can feed image data, you can feed time series data, you can feed protein data or reinforcement learning data. And this architecture will efficiently, similar to text, will allow for efficient processing. A few recent examples of multimodal models or GPT-4 or Palm-E, and there is a new one called Cody that allows you to go from any modality to any modality, which is really fascinating. But the problem is that not many of these models are publicly available, and these models are still very difficult to train and compute intensive to train. And again, these models are not perfect. So we see great promises and great opportunities for generative AI across modalities. But cognitive scientists and other multidisciplinary experts, they bring this limitations of language models into everyone's attentions. And here are some recent works on the limitations of generative AI models. Let me quickly address them. So current AI systems, they're very specialized and brittle. When you interact with ChatGPT and if you ask about your bio, it definitely hallucinates and it comes up with things. It gets many things wrong, but it also gets many things right, but it also gets many things wrong. But what's important that we all have to realize that these models can neither reason nor plan. They just generate content. It's a statistical model that just predicts the next token. And these models, they make stupid mistakes. So they don't use common sense like we do humans, right? So unlike these models, the humans, us, we can learn new tasks quickly and we can understand how the world works. There is nothing about that knowledge in large language models and multimodal models. We can reason and plan, and we can perform the chain of reasoning with an unlimited number of steps, as well as we can take complex tasks and decompose these complex tasks into smaller tasks. We use common sense and we can predict consequences of our actions. And fundamentally right now, when ChatGPT is generating content, it cannot predict consequences of its own actions, which I think is fundamental. So what I think we have to do next, we really have to think about how we teaching and how we allowing machine learning models to learn compared to how we humans learn. Babies learn from observation with initially very little communication, And we accumulate a lot of background knowledge. And what we have to think about is that does common sense emerge from observation and communication from somewhere else? And how do we transfer it into large-scale models? So the next steps, I think, would be for these large-scale pre-trained models is to learn to reason and to learn the cause and effect, learn to plan and learn skills and learn from experiences like we humans do, and not only from positive experiences, but also from negative experiences. And already some research has been evolving in this area in embodied generative AI. And some recent works like the robotics transformer and ChatGPT for robotics are getting us closer to being able to plan and reason with these large-scale models. With all of this like evolution over the last couple of years in generative AI, I think we have been fundamentally overlooking the risks and limitations. And there are many, and I know we started looking more and more into it, specifically focusing on generative AI. For example, a couple of days ago, the Department of Defense announced the establishment of generative AI task force, and the European Union have been issuing regulations to address AI limitations and risks, as well as specifically generative AI limitations. But there is still more that we have to do. Generative AI poses significant security risks. For example, in exploiting vulnerabilities, attackers can use generative AI to create text or code that exploit software vulnerabilities. There is also a risk of data synthesis for attacks. So generative AI can synthesize tons of data, legitimate data, that can lead to data poisoning and invasion of security and malicious activities. There are also a lot of ethical issues. So algorithms have been demonstrated to significantly amplify biases inherent in the training data. These biases, there are many types of biases that these models get wrong. And we have to think about the ways to eliminate these biases. There are other issues like copyright issues and privacy issues. And there are many examples that have happened so far with ChatGPT, for example. There could be personal data that was fed when the models were trained that can be exposed when we interacting with these models. And there are also political implications. So generative AI models, they raise issues around false and misleading information. And these models are probably even right now are being used by adversaries to generate deep fakes and malicious content that appeals to our emotions and that is designed to affect our behaviors and is exploited on social media. These things are already happening, and we don't have a solution to really address these risks. What I think we have to focus more on, where research could go more into looking into the metrics and the benchmarks that we could use, the safeguards that we could develop, we researchers could develop across different dimensions that go beyond performance measures, right? So we want these models to be smart and reason and make decisions, help us to make decisions. But we also need to make sure that these models are transparent, that these models are accountable, that these models are fair and they don't have any biases, as well as these models are robust and they're unbreakable, right? And there have been a lot of efforts, even before ChatGPT was out, right? So, and the community have been actively working on it across these different additional dimensions. In addition to that, there have been benchmarks that are generated by the academic community and industry too, that allow us to make this apple-to-apple comparison when we develop these models, right? To say that, oh, model X is better than model Y on this common set of tasks. But again, this is very much an evolving field, and we haven't solved and we haven't developed the benchmarks that accurately represent model performance and model limitations. This is very much ongoing. And we also have been working on developing these tools and contributing to this huge ecosystem of trusted and responsible AI, focusing specifically on accountability, robustness, transparency, as well as human AI trust, which is right now is a very overloaded term. And I think we still, as an AI community, we are converging on what we mean when we say human AI trust. But we have been developing capabilities that allow us not only calibrate trust, but also learn from these human AI interactions, which I think is fundamental for adopting AI and making sure that we adopting AI in a trusted and responsible manner. And I would like to end my presentation here with this call to action to make sure that we develop our generative AI capabilities and learning from the way that we deploy AI and how we interact with this generative AI and beyond. Thank you.
Thank you, Svitlana. This has been fascinating and excellent. And thank you for sharing your contact information too. So any of the people who are listening or watching or reading about this in a transcript could look up Svitlana Volkova on LinkedIn. And she also provides her email here, svolkova@optima.com. So this has been fascinating. So why don't we chit chat a little bit now about some of the really cool things you've brought up, and maybe how else we can apply them and help our listeners apply them too. So one of the things that I always find interesting about AI and machine learning and data science tools and techniques, being an aerospace engineer by training, uncertainty in results is not really a good thing when you're designing like a plane you're going to put humans in and put up in the sky. And I always find it interesting, even as we look at this, and you were looking at, the more data you provide, the better, it gives you more context, you can make better choices, the uncertainty reduces, the veracity is reduced. But even at the scale you were talking about, 10 to the 24th or whatever, it's still at the top 70%, certainty. So can you talk a little bit about how you see that evolving? And I used to work in corporate strategy at IBM for many years, and I always said there's always a range of uncertainty in anything that you talk about, right? And so this shows how we use these new data science tools and techniques, or newer ones, and there is a range of uncertainty. Can you talk a little bit how you see that evolving? And if you think we'll ever get asymptotic to really being certain from the output of some of these models?
Absolutely. Uncertainty quantification is a huge area of an emerging area of research right now. And you're absolutely right that these models are far from perfect. They have great potential and they are applicable across many domains. But for some domains, for safety critical domains, for the Department of Defense, for example, these models you cannot just simply apply, because you can neither explain them nor you can trust them, right? Because you can calculate uncertainty accurately. So where I think we can go with it next. So first of all, I think learning from multimodal data, as long as we teach these models to look beyond multiple modalities, the more data and more diverse data you bring to the table, this reduces your uncertainty. That's one. The second one, the type of learning. As I said, going from just supervised learning into completely unsupervised in context learning allows us to explore new ways that we can train these models to learn. I think learning from experiences like we do, like reinforcement type of learning skills and being able to share the skills. So if I can only get my experiences and my skills from one AI agent into another AI agent, right? So copy knowledge and copy experiences and copy skills, that would be fundamental. So, and this will absolutely reduce uncertainty. And third, I would say causal, right? So the ability to learn cause and effect. So I think causal reasoning and causal modeling, if we keep marrying, I don't think we really married, even though there have been a few really interesting publications between about LLMs and causal modeling recently from Microsoft Research, but we are only on step one, I think. So the marriage between causal modeling and generative artificial intelligence, and in general artificial intelligence, would get us closer to not only measuring uncertainty correctly, but also modeling and anticipating. So these are the three components that I see.
That's excellent. Well, thank you for validating that there is a range of uncertainty so that everybody understands that, right? And I find it very interesting as you talk about having more data and multimodal data, that's one of the things that artificial intelligence can do. Like you said, a human could, read everything for 22 years, or 22,000 years. Oh my goodness, I don't have time, because then how do I use the data? Because I'll be gone by then, right? And that's one of the values of AI, is that it can comb information and data try to assess the veracity of it, the uncertainty, make sure they're using good data, right? So that's one of the tools to, one of the opportunities with the use of AI, and then using that to increase context, which actually goes beyond what a human can do, right? Because we don't have the time to look at all that information and find it every day. And research comes out with information every day, and the world and humans come out with new ideas every day. And so to leverage the tools to increase the information and context actually will allow us to make, have more insight and hopefully provide better input for better recommendations in the future. So I think this whole confluence of all this is very interesting. And I think it'll be very exciting for many years.
Absolutely. And I absolutely agree with you about complementarity. Humans are good in some things and machines are much better in other things. And I think being able to continue creating, we have been looking into human AI symbiosis for years, right? But I think with the new emerging capabilities of AI, I think we have to rethink how we think and model human AI interactions. And as we discussed before, the human should be first, right? And human is always responsible. But AI can be a great assistant across many domains.
Totally agree with you. I'm sorry, go ahead.
And we already see it, right? So
totally agree with you. And that's one of the things that our reinforcement learning opportunity is to always say the human's responsible for the results. Even if you're using ChatGPT or some other resource, the human is responsible for the results. And that's what we talk to the students about and all professionals too. There was a recent situation, I think, where a lawyer filed a brief or something, and they realized that it was hallucination, from ChatGPT, which was really an issue for them. And so no matter where you are in your role or in your professional development, it matters. You are responsible and you have to check to make sure it's correct.
Absolutely. We are seeking for this expert knowledge from ChatGPT and other types of models, but we have to not being an expert in the field that we're seeking expert knowledge doesn't allow us to validate model outputs, which is bad. And we have to always remember that you triple check, right? These models are great in summarizing and generating additional knowledge and content. But you have to, if you're talking about a specific field that you are not the expert in, I wouldn't trust the knowledge that LLMs return, because
that's a very good point, and I totally agree with you. And on that note, one of the things we're doing in this masterclass series is talk about the different domains that these tools can be used in. And I think what I'm ascertaining from what you shared is that, and really anybody can use ChatGPT. People say, oh, I want to make a new recipe, whatever. And then other people might be saying, what's really going on in the banking industry of blockchain or whatever. It could be a whole range of things. Or what are some of the, the advanced the APTs out there these days? There's all sorts of stuff, that could happen. So what are some of your thoughts about the leverage of generative AI in, some different domains? One of our other masterclass series presentations was on AI and precision oncology, very interesting. And so I'm wondering if you have thoughts on some other domain areas.
Absolutely. I think generative AI will transform will transform education completely. Training and learning, the way we humans get new knowledge and apply this new knowledge, and the way we learn will be transformed by generative AI assistants. The way that we generate content, the way we exchange knowledge will fundamentally be different, even in the next year. And it's already started happening. There have been even institutes stood up specifically focusing on generative AI for education, studying the promises and implications. And because there are both, as always, both sides of the coin, right? There are huge opportunities, but also there are risks, right? These models can be used for cheating, let's say for code generation or for assignment, right? The homework. And we have to make sure that we have the right policies and we have the right tools, honestly, because we can develop tools, and there are tools right now exist that can distinguish between human-generated content and AI-generated content, whether it's a text or an image or it's a speech. There are tools that we could apply to make sure that we mitigating for this. So that one, I think, AI for education. The second one, I think, operations in the information environment and political implications of this generative AI technology. I think there is a huge potential to develop techniques, reasoning technologies that will allow us to understand the information domain better and the effect of generative AI in the information domain, social media interactions, news, how we react to these things and how we perceive these things, and what are the implications of generative AI, because these bots, they can be deployed at scale previously unimagined, and they are really good. They're very convincing. They speak even better than humans, and they generate content that appeals to our preferences, which is very scary, to be honest. So that's another field that I think is interesting. And the third one would be embodied AI. I think allowing this generative AI technology, specifically large language models, to be embodied and explore the environment, learn from the environment, learn from skills and experiences, is also interesting and have a lot of potential.
Well, Svitlana, you are just fascinating. The knowledge you have, how you apply it, and how you communicate it. So, if you were my large language model, I'd be very happy. It's really been wonderful for you to share your passion, your interest, and your knowledge with our audience. So thank you very much for all of this and for being part of our masterclass series. And we look forward to keeping in touch with you. Thank you very much for your time and for your fabulous presentation and discussion.
Thank you so much for inviting me. It was a pleasure. Thank you.